Hi, I'm Dana. I work for Xojo and I've been here since 2006. I'm going to talk to you today about learning programming with Xojo. First, you may be wondering, why Xojo? Well, it's a development environment that will allow you to create 100% fully native applications for both the desktop, including Windows, Mac OS, and Linux, as well as for the web, iOS, which includes both the iPhone and iPad, and also for the Raspberry Pi. Currently, support for Android is in development. You can develop for all of these platforms using the same environment, which includes an IDE, which is the application we're going to use to design our apps, and also a single language of the same name, Xojo. This programming language is powerful, modern, and easy to learn, which you will see throughout this programming course. Xojo is object-oriented, meaning it offers a tremendous amount of flexibility in terms of being able to reuse the code you write, which you can reuse in the development of all of the different kinds of applications that you may want to create. We'll start this course at the very beginning, so download Xojo. You can use the IDE itself on either Mac OS, Windows, or Linux. Multiple distributions are supported. Since my main environment is Mac OS, for the purpose of this course, we will use it, but we'll also be alternating between Windows and Linux from time to time. Go to xojo.com, xojo.com, to download the product. To download the Xojo IDE on your computer, drag and install it by drag and drop on Mac OS or through the installer provided in Windows and Linux. However, before you install it, I suggest you go visit the Xojo system requirements via the resources page where you can see the system requirements themselves. You can get to this page via the download menu from the home page and then go to requirements. The system requirements page is divided into several parts, since on one side we have the IDE itself, which again is the application that we're going to use to create our programs. Then we can also see the different sections that correspond with the minimum requirements of operating systems or the computers that will run the application that we create with Xojo. For example, if we're going to create applications on the desktop, we can see the minimum requirements for running on Windows, Mac OS, and Linux, and also the Raspberry Pi. This is the same place where you can find out browser requirements for the deployment of web applications that you're going to create with Xojo. You can see each major platform and which browsers are supported. So as you scroll down, you can see those, as well as Raspberry Pi, iOS, and Android when available. Here are some of the technical requirements for the server that you will host the web applications you create with Xojo on. In addition to the desktop applications or mobile or web applications, you can also create applications for the console. Console apps are service apps that do not require a graphical user interface or a GUI that you can run in the background, or you can launch from the terminal as helper applications for desktop or web apps, for example. And of course, you can also find the technical requirements for iOS apps and the information on supported versions. Last, you can see the information here about Linux. There are numerous Linux distributions, and depending on your distribution, you may have to configure your installation or run additional applications to use Xojo. Once you've verified your system will be supported and meets all of the necessary minimum requirements, you can go back to the home page and click the download button. Xojo is completely free to use for learning and testing your application. To get started, you're going to need to create a user account. If this is your first time visiting the Xojo website, you'll need to click register and follow the process. But for the purpose of this video, I'm going to just log in here so we can view the download options. The website's going to try to detect your operating system automatically, so you should be able to see the appropriate download link at the top. If not, scroll down for options, or if you need to download for another platform, the options are all below for you. And accessing those versions is as simple as clicking download and starting the download of the product. When you finish, you will see that you have a folder. If you're using Windows, you will only have to run the IDE installer. Inside, you will find the application, which is the IDE Xojo that I mentioned earlier. This is the application we're going to use to build an application. It's the same as we would a text editor to write any text document. An IDE is the application that will allow you to write the code and design the screens to make up your application, as well as manage the rest of the resources you're going to use to compose your application. You'll also find the Xojo IDE to do all the tests, and you'll be able to find bugs and fix them. Other interesting folders include the Examples project folder. This one contains many examples in many different categories that are ready to open and run. And you'll also be able to find a lot about how Xojo works from looking through the Examples folder. For the process of learning from the beginning, we're just going to limit ourselves to run the IDE. Once you launch Xojo, the first screen you will see is a Getting Started page that has links to the various resources available to you and that will allow you to further accelerate the learning curve so you can get up to speed quickly. You have access to a good amount of tutorials that you can also follow along with. They are available in many different categories and different platforms and types, including the Messenger app or serial port tutorial. We have a multitude of video tutorials on our YouTube channel available in several different languages with over 1 million views. They are a great tool if you're looking to learn programming or if you have a specific type of project you want to develop. The same folder I mentioned earlier, the Examples folder, has a lot of content that includes sample applications and code projects. Code examples and the Xojo documentation, which is a collection of everything you need to know about Xojo, from the framework to the available functionalities. It's important that you know what is available, so if you encounter problems or you're not sure what to do next, you'll be able to find the right resource to help you along your way. As we close this screen, we will see the project selector. Here you can choose what type of app you want to create. The top is for desktop, then web, a console application, and an iOS application. The recent projects will also list the last few projects you have worked on. In the templates section, you can find templates that lay out a framework for similar applications that you can use to speed up development. Here we have another way to access the Xojo example projects folder. You can explore it to see if there are example apps for something you may be interested in learning to speed up your own development. If you find something that interests you, you just have to open the project, run it, and then study the code and see how it works. In the case of this course, we're going to use a desktop application. We'll give it a name and press OK. Xojo will create a project skeleton in the IDE that we can use as a starting point. At a glance, you'll notice that the IDE itself is composed with a series of different parts. First, the leftmost area is the project browser. This one is in charge of collecting and displaying all of the elements that we will add to the project, from the windows we want to use in our app interface to the other items we're going to see along this course. You can also see that one of these items is a predefined menu bar that includes the essential menu items for an app. Probably you want to add new menu items to your own apps, and this one is the editor you'll be using for that. The project browser is where you can find two well-differentiated items. The first of these is the app item, and the second is the build settings section. When we have the app item selected and we access the panel inspector, this one lets us modify or set a series of characteristics or properties. For example, we can set the window we want to display by default when the app runs. We can opt not to display any window at all, or as it does by default, to display the window added in a desktop project skeleton, in this case named Window 1. Of course, we'll be able to select any other window we may have added previously to our project. In the inspector panel, we can also set the main menu bar we want to use by default for our app. As in the previous case, we can choose between not using a menu bar at all or use any menu bar we have added to the project. In this case, it's the one added by default to Xojo to the new desktop project skeleton. Without the need to do anything else, you can see that as you select any of the project browser items, the inspector panel changes to display all the properties you can set for that item. We did see previously how to change the properties for the app item, and if we select a window in the project browser, then the inspector panel will change to display the properties that are specific to the selected window. What are some of the properties we can set for a window, you're probably wondering? Well, as you can see, we can set its width, its height, and also the maximum width and height allowed when the user uses the mouse to change the window size. We can also set the frame type we want to use as the visual appearance for the window. By default, it uses document type of frame, but when designing your own apps, you'll need to use other types of windows, and every one of these offers their own specific behavior and are best suitable in functioning different kinds of information that you might want to present to the user. You can also set some of the visual elements for the window, known as widgets. For example, the widget to close the window, the widget to maximize its size, to minimize it, or to display the window at full size on the screen. You can also set the property that defines if the user will be allowed to change the window size or not. In addition, you can decide if you want to set a specific background color for the window or use the system-wide color scheme so it's visually in coordination with the look usually used by most of the apps for their windows under any OS. In the same way, and as we did see for the app item, here you can also find a section that will let you set the menu bar to use in that particular window so it can handle the menu items selected by the user on that menu. For most of the simplest desktop apps, and that will be the ones that we're going to use to create for the first few chapters of this course, having just one menu bar is usually enough. The second of the sections I mentioned before is build settings. In the previous cases, we were able to set the specific behavior for every item in the project. In the case of build setting, we can see that we have a field named shared. This one offers a series of settings that are common to all of the supported operating systems you can run your app on. These properties include the major version, the minor version, the bug version, and the development stage or stage code development, alpha, beta, or the one we should select when we're finally going to deploy our app. We can also set the numeric value for the version, the copyright information, its general description, and the settings in charge to set the location where the app should be compiled and the optimization level, amongst many others. The main difference when compared with other development environments is that the app you'll finally get with Xojo will be 100% native. It doesn't matter if it is for macOS, Windows, or Linux. The result will be the same in all cases, a truly native and truly compiled application, showing the same look and feel, behavior that you would expect from any app under the operating system. In the case of macOS, for example, you can set here if it offers support for dark mode or for all supported operating systems if it's going to use high DPI graphics. Just with the skeleton for this desktop app, simply composed with the by default items and without the need to do anything else, we can click Run to have a fully functional app, in this case for Mac app. We can see that when we move the window, change its size dragging from the borders, it has all of the widgets we previously did set through the inspector panel, and that lets us maximize, minimize, or close by default. And of course, we also have the menu bar set by default. I mean, without the need to do anything else at all, we already have the wires of a fully functional app. And as you can see, our app already automatically supports the features available in the OS. For example, it can detect changing between dark and light modes. Also, if we open the system preferences, we can see that macOS is using the dark mode now. If we change it to light mode, then our app will automatically react to that change, showing all of the user interface components in the light mode. And if we change again to dark mode, our app will react to that, changing its color scheme to the selected one in the system preferences. But let's create our first app so you can see by yourself how easy the process is. Obviously, don't expect a wide range of functionality here. When we access the library, we will access to the wide range of user interface controls that are ready to use, and that will allow us to create our user interface design simply by dragging and dropping them from the library over a window. In fact, you can list these controls in several modes, so you can choose the one that fits better with your own preferences. The interesting thing is that when you put the mouse pointer on any of these library controls, the lower section will show you a brief description with the functionality of that control. That is what the control's use is intended for. For example, the library includes a default button, cancel button, or a generic button you can use for any kind of action. Of course, you can use the text input field or a variation of this one, ensuring that the user input is private. That means that the control will substitute every one of the characters typed by the user with a bullet character. In the library, you will also find text area controls letting you work with the text with style, pop-up menus, or pop-up menus allowing the addition of new entries, or other more complex controls, making it easier to design and compose your user interface, display HTML from a given link, videos, graphic content, etc. As I previously said, all these controls are ready to use with minimal coding from your side. Let's see now how easy it is to design our user interface. Start by selecting a window item, Window 1, from the project browser. We will access next to the inspector panel, and with the item still selected, we will give a new name to the window. In this case, the name will be Main Window. Once you do that change, you'll see the object name is also reflected in the project browser. That means that from now on, we can refer to that object from our code by its new name, Main Window. Let's change also the window title. That is the text shown in the upper bar of a document type window. For that, we type Main Window in the title field of the inspector panel. Let's change also the maximum width and height so they are 500 by 700 respectively. This is the window we're going to use to design our app user interface. With the window still selected, let's go back to the library and drag a label over the window. You'll see a series of guides in the layout editor every time you drag a new window from the library over a window. These guides will help you align the controls with each other and with respect to the containing window margin so that the user interface is visually more appealing. For our example, we will position the label on the upper left side of the window. Once it's done, you can see how a new item has been added to the project browser named by default as Label 1. The project browser hierarchy will let you better understand the existing relationship between our label and the containing object, in this case, the window. So we can see that we have our main window, and this one includes a series of controls. Being one of these is Label 1 label. As Label 1 is the by default name, and it doesn't include that much description, we can change it using the inspector panel. Once again, let's type name label in the name field. Once done, the object name also changes from Label 1 to name label in the project browser hierarchy for the project. So this will be the name we will use from our code to refer to that object. To change the label text itself, we could use the value field in the inspector panel. And as you can see here, when we move our mouse pointer over the control, it displays a pen icon, showing the new panel when we click on it and letting us type to a new text value for the label. For our example, type your name. We can see that the type text is wider than the by default control width. If we want to change the control size, we only need to drag from any of the available size handlers for the selected control, in this case, the label. So let's go back again to the library, and we'll add now a new control so the user can type some text on it. The control in charge of that will be text field. Drag the text field control over the windows, and once again, you'll see the alignment guides in the layout editor, letting us to perfectly align our new control respecting to the already in place ones. Using the inspector panel, we changed the by default name for the object, typing in this case name text field. So we better know that it is a text field where we will expect the user to input their name. We won't change any of the other available properties from the inspector panel, like text color, accepting the tab key character as part of the input, the text alignment, the activation of the spell checking, or limiting the amount of allowed characters, amongst others. In addition, through the inspector panel, we can also set the property to read-only mode, meaning that the user won't be allowed to change its contents. We can see also here some interesting fields under the initial state section, value and hint. What is hint for? This is the text we want to display to the user as a hint about the expected input we expect from the user. For example, if we type here, please type your name, we can see that such text is displayed a little bit attenuated on the control. This text will be displayed by the control once we run our app and will disappear when the user inputs some text in the field. The hint will be shown again if the field is empty. This is also the value field. The text typed here will be displayed by default by the control every time we run the app. As you can see, the hint is not displayed when the control has a text value on it. Let's delete the text from the value property so the control displays the hint. The last control we are going to add to our user interface is a button, a push button control. In this case, we're going to use the default push button, and that means that the user only needs to press the return key in order to execute the action we want to associate with the button. So let's get back to the inspector panel to change its name. And as with the previous cases, you can see how the project browser hierarchy reflects all the new items added to the project. the project browser will show us always all the items that we are adding to our project. If we run the app at this point, we can see that it works and it looks exactly as we designed it in the layout editor, but it lacks any kind of functionality. If we click on the button, we can see how it visually reacts, but has no code to execute in response to that action. As we would expect, if we type a name that is displayed into the text field, we can do it without anything at this point. Let's also try one of the settings we made to the window, the maximum allowed size. As you can see, the window has adjusted the size to the maximum value we did set from the inspector panel. We exit from our example app, and the next thing we're going to do is to put some functionality so a welcome message dialog is displayed when the user clicks on the button. We exit from the app. The way we can link actions to the several controls used in the user interface is quite easy, as you're going to see. We do have a good number of options to do this, but if you look at the upper area in the layout editor, you can see a toolbar whose buttons let you access a series of common functions when working in the layout of your user interface. One of these icons is a pop-up menu whose items let us add several kinds of code items in the selected object. In this case, we will add the one named Event Handler. But what is an event handler, after all? Well, think about it as a specific function that will be fired as an answer to a concrete action. So the code that we type for that action will be executed in that response. Xojo will display this panel every time you select the option to add a new event handler, listing to the available events you can choose from the selected item. As we have our button selected, we are seeing here all of the events we can implement for a push button. By default, the action event is selected, and as you can see in the right side of the panel, there is a description about when and under what conditions the event will be fired. In this case, every time the user clicks on the button using the main button from the mouse or any other supported input device. We can also implement code for the close event, and that would be executed when the control is about to close, which is something that happens when the containing window or any other containing control is closed. We could write code that would be executed as a response to the preparation of the contextual menu when pressing a key in the keyboard, every time the mouse pointer is entering the control area, etc. Choose the action event, and we can see how two interesting things happen once this event handler has been added. The first is that it follows the same behavior we saw during the window layout design. During the window layout, the added controls are reflected in the project hierarchy. Similarly, when adding an event handler, the control hierarchy also displays this. We can see that we added a control, we added an event handler for that control, and when we select it, we access a new editor from the available ones in the Xojo IDE. This one is the code editor, and this is the one we're going to use every time we need to write Xojo code. The first code sentence we're going to type is one that will display a message dialog box. For that, the Xojo framework includes the message box function. Obviously, the name of the available functions, methods, keywords, and other components of the Xojo programming language is something that you will learn over time, which you'll do accessing the available user guides, getting started guides, and the language reference, amongst other available resources. Of course, you can always access the available documentation from the Help menu, and all of the resources are available at docs.xojo.com. If you access the language reference under the Help menu in the Xojo IDE, you'll be able to see all of the information that you may need. To keep everything simpler in this first chapter of this course, focus on what I want to show you, and later we can integrate using the Help feature into our routine. When we first type our message box sentence, we can see a couple of interesting things. The first one is that as you type in the code editor, it will show you the ellipsis character, and this is a hint for the available auto-completion feature. This means that if you press the Tab key, it will bring up a pop-up menu listing all of the available matches you can select for the autocomplete feature. When you're learning a new programming language, this feature is really useful to see what's available, and even when you master it, because it speeds up your typing. In this case, we can see the pop-up menu entries don't make too much sense to us, especially if this is your first time programming and with using Xojo, but we'll talk about what these are intended for very soon. Anyway, among these we can find some we did see briefly, as is the case for menu bar and also message box, the name of the function we want to use. Once we press the return key to confirm the selected item is when an interesting second thing will happen. If I put the mouse pointer over the message box text, we can see how much the lower area of the window tells us about how it should be used. For example, in this case, message box expects to receive a text message as argument, and text or string is one of the most common types of data we handle when coding. That is, in this case, the type is a string. There are several kinds of data types. For example, we have the primitive ones. For example, when we need to do work with integer numeric values with a decimal part, with simple or double precision, and also strings to work with text data. Of course, there are many other data types available and that we will see and use along this course. In this case, and in order to make things simpler, we will limit ourselves to reproduce what message box expects. Type welcome as the message string and done. But if you want to get a deeper look at how to use message box, you can access the specific help available for that item through the contextual menu, selecting, in that case, help for message box entry. As a result, the help window is displayed with a detailed description about its use on every supported platform. In fact, we can read that there's a parameter we need to pass along, and that as the message we want to display, whose data type is string. We can also read about the particularities and specifics related with its use. Even a bit underneath, we can find an example ready to copy and paste in the code editor. So we only need to change the message itself. You'll find this type of help really helpful to learn the Xojo programming language very quickly. So let's get back to the topic. We can see that this line of code is associated with the action event handler for the push button. So it will be executed when the user clicks on it. Let's test it. As we run our example app again, we can see that when we type our name in the text field and we click the button, as expected, the message box shows up displaying our text string. Let's do something a little bit more interesting. So the dialog can display the message along with the text we did type in the text field. Let's figure out how we can achieve this. We did see how we can access the specific help information for the message box. So we can do the same process for the text field. Select the text field item in the project browser and access the contextual menu to access the help for text field entry. As a result, the help window will be open displaying all of the documentation related with the text field use. We already know what the events are for, but what about the properties? When it's about an object-oriented programming language, the properties are the characteristics or attributes specific for a kind of object. An object can be a car in the real world, and the properties or attributes specific to this kind of object could be some things like the number of doors, engine type, the car color, size, wheels. That is, all the cars share the same properties making that car. It's a car, not a bicycle, for example. But the values of the properties, what makes that car, that specific car, can be different from each different car to each other. In this case, the text field has specific properties set. Some of them are read-only, which means that we can only access its stored values but not assign new values to them, while others are read and write, so we can read its stored values and also assign new values to them. Among the multiple available properties for text field, we can find one named value. Value is the property of a text field that stores the text string typed by the user and also the string we can assign via code. As you can see, when we move the mouse pointer over every one of the properties and events or event entries in the help window, you'll see that these are active links. When we put the mouse pointer on the value entry, then we can click on it to access the help page offering the specific information for that property. Here we can see the syntax we have to employ when we access the property in read mode. Any text field, dot, value, equal, and the new value we want to assign to it. And when we want to use the property in write or assign mode, then the syntax is kind of the opposite. We need to define something of string type that we will receive the data contained in the value property of the text field. As we did see before, the help page also offers some use examples just below the main info. For example, here is assigning an empty string to the value property of a text field. This means the text field will empty all of its contents. Armed with this information, we already know how we can access the data typed by the user in our text field, and we already know that we can reference our text field object from code using its name text field. Let's get back to the push button action event to access the code editor so we can add our welcome string to the value typed by the user in the text field. At this point, the question would be, how can we add text string to another one? If when working with number values, we're used to using the plus operator, when it's about adding strings in Xojo, we can also use the plus operator. It's that simple. We already have a text string and we want to add a new one to it. What do we want that second string to be? We already know that it is the text string stored in the value property of our text field object, whose name is nameTextField. NameTextField is an item, an object, and as we did see, it offers a lot of properties. So when we work with objects, how can we access every single one of its properties from code? This is something known as dot notation, and broadly is used amongst multiple object-oriented programming languages like JavaScript, PHP, Swift, Objective-C, and C++, amongst others. So after the object name, nameTextField, we only need to type a dot, and if you press the tab key, you'll be able to access a pop-up menu offering all of the properties, methods, and other language items you can apply and use with that kind of object. Amongst these, you can see the one we're interested in, which is value. So we choose the value entry to complete our line of code. If we put the mouse pointer over the value text, we will see that the lower area of the code editor displays information telling us that this property returns its data as a string data type. This is great because thanks to the fact that it returns a string, it means we can add it to the welcome string we already had for our message box sentence. Let's run our app again to see how this works. We type a name, click on the button, and as expected, we can see that if we add two strings, that is done literally. The first string welcome, and right after it without spaces, the value typed in the text field. We want to apply some basic formatting to it. We could simply add a space between the text strings, or we can separate them using an end of line. How can we do that? Well, the Xojo programming language includes a series of helper functions already available, and one of these is end of line. If we type end of line, we can see how the code editor auto-completes it, and of course this function gives us a string value. After all, an end of line is also text. We run our app again. We type a name, click on the button, and we can see now how the dialog displays our welcome message as the dialog title, and right after it, in a new line, the text we did type in the text field. As you can see, all the graphical items in our app are 100% native, as you would expect from any app on the Mac, and in fact, it is a truly native macOS application. It's that simple. We did our user interface design right away with drag and drop, and using just a line of code to display a welcome message dialog, including in addition the text typed by the user in the text field. As you can see, programming with Xojo is really easy and fun. And the best part, everything we did will run, look, and behave as it should on any of the supported operating systems, including macOS, Windows, and Linux. Expanding our app functionality is something that we will see in the next chapter of this course. Now it's time for you to download and install Xojo on your computer in case you have not done so already, and experiment with this or any other example project. Please subscribe to our YouTube channel to be notified when future videos are available.